This is the mini lesson for 10.4. So we've already explored the relationship between angle measures and side lengths to know that the largest side length lies opposite the largest angle. So now we're going to look at some conditions for triangles. So we want to know if it's possible to make a triangle with any three side lengths. So I'm going to use some pasta here to represent that. So if I start to try to put these two small sides together, obviously that doesn't work, so I need to open up the angle. And this last side is still too long, so I have to continue to open up this angle. Still not working. Open it up some more. Still's not matching up. You can see here that if I even made this a straight line, this is never going to turn into a triangle, because no matter what, when I put an angle here and I pop in this third side, there's always overhang on either side. So I'm not able to make a triangle with any three given side lengths. There has to be certain conditions. So when I look at that and I put those two smaller ones together, I notice that these two smaller ones are not as big as the longest one when you put them together. I'm going to make this shorter. So it's still the longest side. Now I'm going to see if I could make this work and turn it into a triangle. And it looks like I am now able to. So a relationship that I'm seeing is the two shorter sides together have to be larger than the longest side of the triangle. So all by itself, this piece here is longer than this one, and it's longer than this one, but it is not longer than the two combined. So let's look in our book on page 534. And this rule is called the triangle inequality theorem. And it states that the sum, remember with addition, of the lengths of any two sides of the triangle is greater than the length of the third. So let's look at that. So I'm able to just look at side lengths and determine whether it's possible to form a triangle. So if I take the two shorter sides, 3 plus 2.9, they have to be greater than the largest side. So when I add this together, I get 5.9, which is greater than 5. So yes, this is going to make a triangle. If I take, I'm going to jump to 3, the two shorter sides, 10 plus 5, needs to be greater than the longest side. 15 is not greater than 21. This will not make a triangle. So I think you can probably figure out the rest of those. We're going to move on to some conditions for the third side of a triangle. So in each of the following, we're given the length of two sides of the triangle. What can we conclude about the third length? So I have to make two different conclusions. One, I need to make the conclusion that this third length is going to be the shortest side, or one of the two shorter. I'm going to call it one of the shorter sides. If it's one of the shorter sides, then this is the longest side. So the sum of the two shorter sides, 8 plus x, has to be greater than the longest side. So I can algebraically solve this. Subtract 8 from both sides. X needs to be greater than 2. Now that's only if x is one of the two shorter sides. But what if x is the longest side? If that's the case, if this is the longest side, these are the two shorter sides. So 10 plus 8, sum of the two shorter, must be greater than the longest. 18 is greater than x. So I need to have these two conditions met. So I can actually write this together. X has to be greater than 2. X greater than 2. But x is smaller than 18 and smaller than 18. So I can write it as one inequality statement. So I'm going to try another one. I'm going to take 13 because there's a little more room. So I have to make two different assumptions. I'm going to assume that x is one of the two shorter sides. If that's the case, these are the two shorter sides. So 3 plus x must be larger than the longest side. If I algebraically solve it, I get x is greater than 8. So the side has to be bigger than 8. But what if this is the longest side? If it's the longest side, then these are the two shorter sides. So then 11 plus the 3 has to be greater than my x. 11 plus 3 is 14. 14 has to be larger than x. So I'm going to write this all together. X is bigger than 8. X bigger than 8. But x is smaller than 14. X is smaller than 14. So if x is somewhere in the range, bigger than 8, smaller than 14, I will be able to create a triangle. Otherwise, I will not. This is the end of the lesson.